Another common business problem. In this case, we don't know how much we're actually paying for the merchandise, okay? But we're told the payment was made in the form of a non-interest bearing note. Well, let's talk about that. We talked about this in class. I want you to realize this. Non-interest bearing note has interest. Non-interest bearing note is like military intelligence. You can talk about it, but it doesn't truly exist. Okay? It's like string band music. It doesn't really count as music. So, there is interest. And we're going to make 6 annual payments. So 6 annual payments, and we buy it on 13, payment was made, and we're going to pay on each September 30th beginning 2016, okay? So the trick here is that you have to take a look at this and realize that what's happening is that we have an offset here. Okay? The first payment, if this was an ordinary annuity, not a deferred annuity, not an annuity due, but a deferred, because we buy the merchandise 2013. The first payment, if it were an ordinary annuity, would be 2014. Our first payment is 2016. So we're deferring it for 2 years. So what we need to do is figure out how we're going to do this. We're going to make 6 annual payments, and we're told that the appropriate interest rate is 15%. Okay, so we can do this one of 2 ways. We can figure out the factor for the present value of an annuity for 8 years, and then subtract the present value of an ordinary annuity for 2 years. Or we can take the present value of an ordinary annuity for 6 years, figure out the present value of the ordinary annuity for 2 years, and subtract it. Either case will give us the same number. So let's take a look and try this, okay? I'm going to do it what I consider to be the easier way. I need the present value of an annuity of $5,200. So let me get the present value of an ordinary annuity chart. Present value, ordinary annuity. And good, my chart doesn't have 15% on it, so I'd have to Google another chart to come up with that. But I can figure out about where it's going to be. It's for 6 years. So it's going to be between 12 and 20, okay? And it turns out that it is. The actual value there is 378,488. So that's the factor, and that's for I equals 15 and N equals 6. So my factor there comes out to 3.78448. And that comes out to, you know, I'm not going to even try to do that in my head. That would be ugly. So 5200 times 3.78448, $19,679.29 and 6 mils. That's for 6 payments. But that amount right there, we have to now come up with the present value of that sum, because that's what the sum's going to be 6 years from now. But we're not going to start making payments for 2 years. So we now need to come up with the present value of that sum, which, again, we have to go look at the chart. But now we're looking for the present value of the sum for n equals 2 for the 2 years that we've offset, and the I is still 15. And when we come up with that, we find that that factor is 0.75614. Multiply that by the sum, 19,679.296. So multiply that by our factor, 0.75614. $14,880.30. $14,880.30. And that's what we need. Okay. The trick there, remember we had that offset.